Hello everyone, welcome back to another AP Physics 1 daily problem. Today we'll be going over the MIT AP Physics 1 workbook. We'll be going over question 2 and 3 of the dynamics section. And without a further ado, let's go ahead and answer the question. A 2 kilogram block slides down a 30-degree incline as shown above with an acceleration of 2 meters per second squared. Which of the following diagrams best represents the gravitational force, W, the frictional force, F, and the normal force, and that act on the block? And then we have our answer choices. So if you guys remember, free body diagrams are a diagram of an object that with the forces acting on it. So in this case, we have the weight force, or the gravitational force, the frictional force, and the normal force. So if you remember clearly, guys, an object, so let's say we have this box, right? On a flat table, it's going to have the gravitational force always acting downwards towards the earth, right? So W, and it's going to have normal force because normal force is always perpendicular to the surface, and we can see our surface is right here. So the normal force is going to be pointing up, so at N, and then let's say the object is pushed this way. Since the object is pushed to the left, friction is always the opposite direction of the motion. So since we're pushing to the left, our friction is going to be pushing into the right. And most of the time they'll want you to have it on the floor or the surface of the object to show that it's acting on the surface. That's where it's getting the friction from, and this will be represented as an F. Now, you might be wondering, how do we transition this into this in inclined plane? Well, it's pretty simple actually. You just draw the same thing, knowing what you know. We just go ahead and draw our surface. Since it's a slanted table, we go ahead and draw our object, the box, and then we just follow our steps. We know that the weight force or the gravitational force is always acting downward. Downward, guys. So remember, downward. So if we have our axis, downward is just putting a down arrow. So we have our center here, and we're just going to put an arrow down right here. This is our gravitational force. And our normal force is always perpendicular. And if you guys don't remember, perpendicular is just making a 90-degree angle. So here, this is perpendicular because they make 90-degree angle. So to make a 90-degree angle, we would just draw a line straight down the middle, right? So that means our normal force would be pointing up this way, and for normal force. And it says, with this arrow, it represents that the object is sliding to the left. And since that object is sliding to the left, as I said, the frictional force always opposes the direction of the motion. So that means if we're pointed down to the left, we're going to have friction acting in the right. And remember, as I said, they like to have it on the floor, on the surface of it. So we have there our F. And if we look at our images, which one best represents our diagram over here, I would say that choice D matches this up perfectly. And then question 3 says, which of the following correctly indicates the magnitude of the forces acting up and down the incline? So we have to remember, guys, that in the equation, in a question like this, where we need to make our up and down, it says we have to choose where do we want our axis. So me personally, I would just draw a line down here to have the normal forces acting straight up the axis, and then having our surface as the x-axis. And now we have to choose, do we want down the slope to be negative or do we want it to be positive? Me personally, to make it easier, I would make it positive and then the right negative, because then we have our force friction going the negative direction, showing that it's slowing down. With that said, we can go ahead and draw our free body diagram as we said, which was choice D. So we have normal force acting up, and then we have force friction this way, and we have weight force down there. And as you can see right here, we have the weight force split into the x and into the y components. So with that being said, we have to go and split it up into the x and y components. For the y, we would have y, so the weight in the y, and then we would have is equal to, remember that this is 30 degrees. Since this is 30 degrees down here, we would use this, our angle identities. We can make this also 30 degrees. And doing our trigonometry, we can see that this is opposite and this is hypotenuse. So that is for x. And then for the y, it would be adjacent over hypotenuse. So that would be cosine of theta is equal to, and since this was adjacent over hypotenuse, this would be W, but to get rid of the W, you would multiply by W, so it would be cosine of theta times W, and for the X, it would be Wx times sine theta of W. And we know that our force normal is just mass times gravity, the same as our weight force, but in this case, it is not a flat surface. So our normal force is actually going to be equal to our weight in the y direction. And we know that our force friction, if we remember, force friction is equal to mu times force normal. And to find all this, we can go ahead and use the F equals mass times acceleration equation. And since we have the acceleration of 2 meters per second squared, we can go ahead and plug this in to find our value of mu and all the forces acting down and up the ramp. With that being said, let's go ahead and plug in these values. Now that we have all our values, we can go ahead and start plugging in what we need in our equations. So using the F equals ma equation, we can go ahead and solve for all the forces acting in both directions, the y and the x. So for our force y, we're going to have Fy is equal to mass times acceleration. And forces acting in the y is just going to be our normal force and our weight, gravity, in the y direction. Because remember, this is at an angle, so we want the one in the y direction. So if we do that, we're going to have our force normal, and since this is pointing upwards, it's positive, so positive force normal minus our weight in the y direction, or gravitational force, is equal to mass times acceleration. And you might be saying, well, our force normal and our weight in the y are both equal to each other, so wouldn't this just be 0? And you're actually correct. And that's a good thing that it's equal to 0. Because if our force normal was greater, then we would have the object going upwards, which is just not something that we want. And if our weight in the y direction was greater, then the object would be going in through the ramp, causing some damage, and we don't want that either. So this equaling 0 is actually the best thing to happen for us, and means that our equation is actually working in the real life scenario. So that leaves us to finding the forces of the the forces acting in the x direction. And the forces acting in the x direction, you would have two. You would have the gravitational force in the x. Okay, so I'm sorry about that, but based off our diagram that I wrote earlier, you'd have forces acting in the x. From the yx, you'd have that pointing down this ramp, and we said that down the ramp is positive, so that'd be positive. So we'd have positive Wx, and we'd have force friction is acting in the right. Force friction is pulling it, and we said to the right is negative, so that would be minus force friction, and that equals mass times acceleration. And then plugging in our values, we know that Wx is 9.8 minus force friction is mu times force normal, which we said is 16.974, is equal to mass, which was 2, and the acceleration, which was 2. Now, as you can see, the only unknown variable is our mu, and we can solve for mu by getting mu all by itself. And once we do that, we get mu is equal to 0.342. Now that we have mu is equal to 0.342, we can go ahead and see if this is true, plugging it in to see if it equals 4, and going ahead and plugging this back in, we have 9.8 minus 0.342 times 16.974 is equal to 2 times 2. This gives us 9.8 minus 5.8 is equal to 4. 9.8 minus 5.8 is 4 equals 4, meaning our calculations were correct. So now that we know that, we have to remember what the question was asking in the first place. Question 3 is saying, which of the following correctly indicates the magnitudes of the forces acting up and down the incline? And if we remember our diagram, we said acting down the incline is positive and acting up the incline is negative. So we need to find what positive and what negative forces are acting on it, and we have to associate that with our direction. And since we said positive is acting down the incline, our positive force is going to be what's acting down the plane, and our negative force is going to be what's acting up the plane based off our direction. And if we look, we said acting up down the plane would be positive weight x, and the positive weight x is 9.8. So we said 9.8 acting down the plane, and we said our negative is our force friction, and the negative value of force friction we calculated it to be 5.8. So that would be 5.8, and since we said negative is up the plane, it'd be 5.8 up the plane. And looking at our values, you might be saying, well, I don't see anything that matches up. And the reason being is there are two constants for gravity. Well, it's technically one, but there are two versions. There's 9.8 or 9.81, and then there's 10. Some people just round this all the way up to 10, and when we round that up to 10, you would expect this 9.8 to round up to 10, and this 5.8 to round up to 6. And if we look at our answer choices, we can see that choice D finally matches us up. So what I would recommend you guys to do is stick to 9.8 or 10. It's up to you. And I promise you'll get the same grade no matter what if someone uses 9.8 or 10. And if you're in the MCQ and you see that they've used 10 or they used 9.8 and used another thing, your answer should be very close. As you see, our answer choice was only 0.2 away from both answer choices. But that leads us to choice D. So I know that this was a very tough explanation. If you don't understand anything, please comment down below. I'll love to just reply to all your comments and make sure that you guys understand. And I hope you found this video helpful. And remember, guys, to enjoy your life.